Okay, welcome back class 8th. Okay, and student, today I am with part 6, okay, of the same chapter, an operating system. In the previous video we have been discussed about the multi-processor operating system and RTOS operating system, that is real-time operating system. Today I am going to pick last two operating systems, that is multi-threading and distributed. Okay, so let's start with the multi-threading operating system. The definition of the multi-threading operating system is it's allow to share the different parts of the program by the multiple users simultaneously. What I said, it allows uses or access of the different parts of the programs by the multiple users simultaneously, which means suppose this is a part of program, user 1, at the same time some part of program, suppose this part is accessed by user 1, this is accessed by user 2, this part is accessing by user 3, and this part is accessing by user 4 at the same time. What I said, simultaneously. Okay, so this is something done through the multi-threading operating system. Let's discuss little deep about it. Okay, I hope you have understood what is the role of multi-threading operating system. It actually allows the multiple users access the same program, if even a different part of the same program, a different parts of the same program simultaneously. Okay, let's discuss little deep. I told you about multitasking. Okay, in multitasking operating system, I told you that the multiple tasks can perform at the same time. Okay, and multi-threading, both are different. Okay, multi-threading, in multi-threading you can also say that, sir, you told me that you can use a multiple different parts of the same program by the multiple users simultaneously. It is the same like this, that just like a multitasking is also multitasking allows the performing multiple tasks at the same time. You are also doing this, but there is a difference. Multitasking and multi-threading, both are the different, because in the multitasking there is one CPU. Here also we have one CPU. In multi-threading, suppose three programs, Excel, Word, and you are doing net surfing. The same program you are doing here, three different programs, Excel, Word, and you are doing net surfing. See, in the multiple tasking, the same CPU will allow you to access the three different process or three different programs at the same time, or three different tasks at the same time. But this CPU will allow or will assign different part of memory for these tasks, memory 1, memory 2, and memory 3. Okay, if you are doing this, then CPU will hold this next process. It will take Excel. Once you switched on to the Word, then CPU will hold to Excel and move on to the Word. Okay, once you are moving to the net and switch to the net, internet or browsing, then CPU hold this Word document and move to the net, which means CPU is switching from one process to another process to another by holding the previous one. Okay, that's why CPU have to provide them different memories. But here, which means it multitasking operating system definitely increase your, you know, economical it is not good because it requires much memory. But here we will work, CPU will divide threads, thread 1, thread 2 and thread 3. Okay, instead of assigning different memories to different tasks, it will share a single memory. Single memory means all the different tasks will share the single memory by the CPU. Here multi-threading operating systems are much economical than multitasking operating system because we don't need much of memory, because all the different tasks are sharing the common memory. Okay, this is something threading, multi-threading. Now let's understand what is the thread. There is a difference between thread and process. If we talk about the multitasking, all the multitasking channel, or you can say multitasking work, can be managed by only operating system, but multi-threading managed by user itself. Okay, process means what? Process is something, a program or set of instruction being executed. This is something process. If you open an Excel, this is something a process. If you open a Word, this is something a process. If you're browsing a net, this is something a process. Okay, but thread is a small light-weighted process inside a process. You can say thread is a small process within a process, main process. Okay, it's a small light-weighted process, right? So we use the light-weighted process. Whenever you use a multi-threading operating system, you don't require a different memory slot or different memory segment for the different tasks. The very live example of multi-threading operating system is the online games. Online games. Okay, like PUBG, very famous game nowadays. PUBG, you are using the same program, you are using the different part of the same program. At the same time, your friend are using different parts of the of the program of the same game, same program on the LAN or any other network. Suppose you can see that in the PUBG the multiple users can play, multiple users are sharing. In fact, we will say multiple users are sharing, or you can say multiple friends are sharing the same game, same program simultaneously. You don't need to wait. Here CPU are switching, they have to wait. Excel have to wait for Word have to wait for browser, because they have different memory slot. I think now you should understand very clearly. They have to wait, but here your multiple friends playing PUBG simultaneously. You don't need to wait. You are playing, your friend circle are playing at the same time, just because you are not sharing, each and every users are not sharing the different memory slot. They are working with the common memory, they are sharing the common resources and common memory. Okay, so this is something multi-threading operating system. I hope you have understood once I have introduced this PUBG game, right? So this is something, a multi-threading operating system. Just a second. Okay. So uh, student, again I cannot upload the large videos, so I have to stop this video right now. So still we have left with one more operating system, that is distributed, that we will discuss in our next video, which will be the 7th part, and then we will conclude with the first chapter. I think functional areas also we have to discuss, so we will discuss in the same video. Okay, till then student, take care, stay home, stay safe. Thank you so much. Bye bye.